Hi, my name is Joshua from TAG. In this video, I will introduce us to data operators in R. An operator is a symbol that tells the compiler to perform specific mathematical or logical manipulations. In R, there are 5 in number. The first, arithmetic operators, assignment operators, relational operators, logical operators, and special operators. As we proceed, we will see that in our previous videos, there are some of these operators that we have used. So this video would help us have a good understanding of these operators and how to go about writing our codes. So the first one is the assignment operators, which we have used when we talked on how to use R as our basic calculator. So you could see we have like 3 columns, one for operator, description, and example. So this is the first operator, plus. We use it in adding 2 operands or unary plus. So this is 2 plus 3. You write this on either your editor pane or the console pane, and you see the result as 5. Same with minus. Subtract 2 operands, 5 minus 3. Multiplication, division, and then this raised to the power. So left operand raised to the power of right. So this is 2 raised to the power of 3. 2 multiplied by 2 by 2. That's it. So we have these special ones among the class of the arithmetic operators, and there are 2 in number. The first is where we have this double percentage sign, and what it does is it produces the remainder when we divide 2 operands. So this particular example is called the modular division. So when we say 5% 2, and we see the result as 1, so what is actually giving us is just the remainder when we have the division of 5 by 2. So in our basic mathematics, you would say, how many times can we have 2 in 5? As 2 times, remaining 1. So in this division, it only provides us the remainder. And so the other type is called the flow division, and this is just the reverse of the modular division. The modular division gives the remainder, the flow division gives the whole number. An example is what we have here: 7% divided by percent 3, and then we have our result to be 2. So it means we can have 3 twice in 7, and we have a remainder of 1. So these are examples in which we would see in the practical section where I created a vector and I have another vector, and then I perform what I call a column wise addition. So this is 2 plus 8 giving us 10.0, 5 plus 3 giving us 8, and then 6 plus 4 giving us 10. So one of the conditions that must be fulfilled here when adding vectors together is that they must be of the same length. So the length of vector v in this case is 3, that is 1, 2, 3 values are inside that variable v, and for variable t the length is also 3, 8, 3, and 4. So in this case it would be easy for us to have the addition, the subtraction, and any kind of it. So this is subtraction, and then we could say the same column wise subtraction again: multiplication, division, percentage raised to the power, and then percent divided by percent, which we know as our flow division, and for the one on top we know it as our modular division. So we have learned about assignment operators initially, and we specifically noted that in R, this equal to sign is exclusively used for assigning variable. So there are limitations, but we need to have that at the back of our mind. So in the situation where we want to tell us that the left hand side is equal to the right hand side, as we used to do in mathematics, so you won't use the single equal to, you will use the double equal to, which we'll see as we proceed. So this is the less than, I call this the less than assignment operator. Here you could say x is assigned to 15. So anywhere you see you want to see 15, you could just easily print out x. And then we have it doubled here, the less than sign being doubled. It is just still the same thing with what we have on top. We have the greater than assignment operator, and then we could see an example there, and we have it being doubled, which is more or less the same thing. So people rarely use this double because it's same with the one which is single. So this is another operator, we call it the relational operator. So this operator takes two operands and gives out a logical statement. For instance, the first one is this one that we call the greater than, and so it true if left operand is greater than the right operand, it will give us true. So for instance, we are testing here, we are saying 2 is greater than 3. So it is not possible. 2 is not greater than 3. So the result is going to give us something logical, either true or false. And in this case, it is false. So we have less than, and here an example is 2 less than 3. So here is true. So the reverse would have been the case if it is 3 less than 2. It would have been false. And so one of the ways we can write greater than or equals to in R is what we have done here. So this is 2 is greater than or equals to 3. So this condition is wrong because 2 is not greater than 3. At the same time, 2 is not equals to 3. So this is false. So here we have less than or equals to. So this is true if left operand is less than or equal to the right operand. Look at it. We have 2 less than or equals to 3. So in this case, 2 is less than 3. So that particular one is right, but 2 is not equals to 3. So R is used to giving us false. So it is less than but not equals to. So here we have true if left operand is equal to the right operand. And this was exactly what I was saying when we were talking about assignment operator, and we were talking about the equal to exclusively used for assigning variables in R. So if you want to achieve the phenomenon where you would have both left equals the right hand side, so what you would do is to use the double equals to sign. And then anytime we are doing something that has to do with not equals to, this is the way we write it in R. You use the exclamation mark, that's this sign, the key, underneath function 1 on your keyboard, and then you put the equal to. So it means this is not equals to this. So here 2 is not equals to 3. So this condition is true. So these are examples of relational operators, and what is going on here, like I explained with other examples, are just the column-wise relationship. So this is logical operators. This is one of the second to the last operators before we reach the special operator. So in these logical operators, they are basically, there are 3 in number: the and, the or, and this one where we are trying to negate whether one is true or negate it when it's false. So here and returns s if x is false, otherwise output will be true. Look at it, if both elements are true. So I actually put this in bracket for us to have like a good summary of what the AND condition does. So it only prints true when both elements are true, that is, both operands are true. So the example I used here is not something that is logical, but in R, when you have like non-zero values, non-zero, non-negative, it would always see it as true. So when I have 2 and 3, it means true and true. So definitely it's going to give me true. It's going to give me what we have, like on the right hand side, that's 3. And then look at what we have here is 0 and 3. So we have 1 that is false. So this completely negates the condition. And so it's more like false and true. So this is going to give us false. And we have here false and false. So definitely it's going to give us false. The only condition where we will have true is when both elements, both operands are true, as we have on top. That is when we have true and true. So this is the OR condition. The OR condition is quite different. Output will be true if one of the elements is true. So as long as one is true, the output will be true. So here we have 2 or 3. Here both of them are true. We are expecting true. Here it is false or true, 0 or 3. We are having true. Don't be surprised, because here it's false, but at least we have a true. So as long as one of it is true, it prints out true as a result. The only condition that would make it not give us true is when we have two scenarios where both elements are false. That's when we have it printing out false. And this other one returns true if S is true, false otherwise. It gives the opposite logical value. So this is it. 1 is true, and here I'm saying please give me the opposite of true, and the opposite of true is false. So in a situation where I say please give me the opposite of 0, 0 is false, the opposite of 0 would give me true. So what we have and or is still the same thing with these two examples we have above. So the last type of operators we have is the special operators, and it is essential we understand all these data operators in R, because in this videos, this channel, what I am actually trying to do is to build from scratch people who are interested in understanding, gaining full understanding of the usage of the R programming for data science or data analytics projects. So in this case of special operators, I just provided 3 of them. So we have this one where we have the full colon. So what it does, it's simple. It creates the series of numbers in sequence for a vector. So I am creating a vector, I'm creating a variable, and then I use the assignment operator, and I say 2 full colon 8. So what I'm saying is that give me values ranging from 2 to 8. And when I printed X, I have 2, 3, 4, 5, 6, 7, and 8. Another very interesting one is this percent in percent. So this operator is used to identify if an element belongs to a vector. So we're just trying to do a check. Like we are looking at scenarios where we have a common factor. The common factor. Like, do we have a situation where a value that we have here is also present here? So if it is present, it gives true on several areas where it is present, and otherwise it gives false. So an example is what we have done here. We have created a variable called X as values ranging from 2 to 8, and we are creating a new variable called 5. Now the question here is, we are saying y percent in percent of S. The question is, can I find the value that we have in y? Can I find this value also in X? It's just like a check, and then it tells me that it's true, you can find it, because 5 is actually among numbers ranging from 2 to 8. But in a situation where my y is programmed as 11, and I'm saying y percent in percent of S, definitely you won't have it as true, it would be false instead. So the last example under the special operator is this percent times percent. In the case of arithmetic operators, we have an example of percent divided by percent, and that we call the flow division that gives the whole number. The modular division gives the remainder. Don't forget those two things, because we would make use of them in future videos when we are learning how to create functions and packages. So now this operator is used to multiply a matrix with its transpose. So M, for instance, we are creating a matrix, and maybe in subsequent videos would also do something on matrix, algebra, and some other things. So we have M equals matrix. We have this C. This is the data we want to use in forming the matrix. We will still get to that level when we are talking about data types in R. So we have matrix 2, 6, 5, 1, 10, 4. That is the data we want to use in creating the matrix, and we have the number of rows against the number of column 3. and then we are saying by row condition minimize, and then we are saying by row condition is true. So I have created the matrix and I stored the result in an object called M. And now look at what I'm doing. I'm trying to get the transpose of this matrix. Look at the easiest way to do this is to say M percent by percent T. T is a function from the base package that helps us in calculating the transpose of a particular matrix. So we have T and then we have the M with it. So here what we are doing is we are multiplying the matrix with its transpose, and then we are storing the result in an object called T. From a basic understanding of what a matrix is, so when we talk about a matrix could be defined by the numbers of rows, as we have supplied some arguments for rows and column, and then the transpose is just like you are transposing it, like you have something in this form and you are turning it around this way. And so when you multiply this, sometimes it could change the dimension of the matrix. So we would go to the practical section right now, and that would be in the next video. So please endeavor to watch the next video to have a full understanding of what data operators are in R. If you find this video very interesting, please endeavor to subscribe, and you can also press the notification bell so you will be informed anytime I share a video on my channel. And please also share with your friends, colleagues in other parts of the world. Thank you very much for your time. God bless you.